Okay, hey guys. So what I'm going to do right now is I'm going to work through the example stats lab that I posted the other day. And the first thing I should point out to you is that in the grand tradition that you're familiar with at this point in this class, I made a mistake. I pulled question 1 and let's see, did I do it with question 2 too? All right. I pulled question 1 and question 2 from an old stats lab that actually used a different data set from the one that I wanted you to use. Up here I said states.save, okay? So we're going to go through and I'm going to show you how to do this question or do these questions. And I'm going to make some changes in this document and then I'll post it again in case you haven't looked at it. All of which is to say, 1 and 2 you weren't able to do if you've done it thus far. I apologize for that. So let's go. Question 1, please identify the mean, median, and standard deviation for the gay therm variable. All right, so we can't do gay therm, right? So what we're going to do instead is that we are going to find the mean, median, and standard deviation for this variable right here. Number 8, black percentage. Okay. And that's just the percent black in each of the 50 states. So to find the mean, median, and standard deviation, I'm going to go to Analyze. I'm going to go to Descriptive Statistics, and I'm going to go to Frequencies. Frequencies, I'm going to find black percentage. And I'm going to remember I got to go into Statistics. I'll mark the mean, median, and standard deviation. And then I'll hit Continue. All right. Off we go. All right. So the mean here is that the mean is 10.3%. The median is 7.1%. And the standard deviation is 9.7. Okay. So that would be the first thing that you'd answer on this question. Okay. Now, looking to the second part of this question. Is the mean or median a better measure of the central tendency of the variable? Well, of course, right, in order to understand that, we need to look for the presence of outliers. So let's scroll down here. Now, we've got these states down here, right? We seem to have a bunch of states. Sorry, SPSS is being weird on me. We seem to have a bunch of states where the it sort of caps at 21 here, and then you've got some like 6 or 7 states. However, there's not one significant outlier or 2 significant outliers that's driving it. This would be one where if you said to me, if you made the right argument for the mean or the median, you would be fine. Your argument for the mean would be, look, you always take the mean unless there's a good reason not to. I don't see a good reason not to, so the mean is a better measure of central tendency. You could also argue the median for me by saying, look, what we care about is the average, we care about what the average state, how many African Americans are in the average state. What is the average state's experience, okay? Then if we go back and we look at the third part of this question, we can say, what do these results suggest about, in this case, it would be something like blacks in the United States. Well, going back to the results, we could say that, like, look, you could just do this from the mean and the standard deviation. You could say that sort of like, that the percentage of black clearly ranges between basically, because remember the standard deviation tells us basically, I think, and Sean, this is for you. Standard deviation tells us what tells us if you go to the outside of this range, you'll capture about 70%. So what you could say, and you could also confirm this by looking down at these tables, right? You confirm this by saying that, look, about 70% of the American states have between 0 and 20% of their population is African American. And that would be fine. If you went, that actually would be a perfectly respectable answer to this question. You could also say this suggests that there's a wide range of states that sort of like, since the standard deviation is almost as big as the mean, it kind of implies that we're all over the place. So again, and I should say in this case, I'm less concerned with your interpretation than although your interpretation is important, right? But if you just said in your stats lab, the mean, the median, and the standard deviation, if you put that in, that's worth about 7 to 8 points, okay? So as long as you can get those numbers, you're doing just fine. Let's go to question 2. Do more women or men believe that gun control regulations should be do more women or men believe gun control regulations should be strengthened? Do these results suggest a gender divide in American attitudes towards gun control? Now, what I'm asking you here is to take one variable, here's my little toothpick pointer, all right, and divide it in terms of another variable, all right? That's a classic crosstab question. So let's go in, and we're going to do a crosstab, only we're going to do it for the Bush 2004%, all right? Since we don't have the right data set for this. So to do a crosstab, I go Analyze, Descriptive Statistics, Crosstabs. All right. I'm going to do, what did I say? I'm going to do Bush 04, and then I believe I have a gender variable. Did they call it sex? Do I not have a gender variable? That's whack. There's got to be something here, right? I don't see anything. How about that? All right, so let's divide it in terms of Hispanic or not. All right, so basically we're going to go ahead. So when you do a crosstab, just make sure one of your variables is here, one of your variables is here. And they were on the crosstab. And that's whack. I did it wrong. So let's go back up. Let's pick different variables. Let's go to Descriptive Statistics. Not that. Analyze. Remember, this is good. This will show you how to get to crosstabs. Really reinforce the lesson here. Descriptive Statistics. Crosstabs. I'm going to take out Hispanic. And then crapiola. I think this data set kind of sucks. Yeah. Anyway, when I ask you for a crosstab, I will tell you what. I will pull up the GSS data that this comes from, and I will give you a real example of a crosstab, and I will explain it there. Again, I'm sorry for the confusion. If you're doing it like this, I can only imagine or if I'm doing it like this, I can only imagine how you're doing. All right, okay. Question 3. Scroll down here so I know you can see. The variables for this question are Bush 04 and Turnout 04. So we're back on the states data set. Is there a real systematic relationship between a state's turnout in 2004 and the percentage of its vote that went to Bush? How strong is this relationship? When I ask you about a real systematic relationship between two variables, that is a correlation. All right, I want you to show me that you can do a correlation. We're going to go back and we're going to go to states and we're going to go to do a correlation. Analyze. Descriptive Statistics. No, I lied. Correlate. And then remember, always bivariate correlations. So I go to bivariate. What did I say my variables were? I said my variables were Bush 04 and Turnout 04. So this is kind of cool, right? We're asking if basically what we're asking is in states with high turnout, how did Bush do versus in states with how low turnout? Just so we know, voter turnout is the percentage of eligible voters who show up. Let's see what we got here. Maybe it'll be cool. Okay. Running a correlation. Okay. First thing that we look at in a correlation coefficient is that we want to make sure, you guys can't see this, tilting down. Yeah, good. First thing that we do in a correlation coefficient is that we look to see if it is statistically significant. So we go here to the sig2 tail test. We look, we see that the sig2 tail test is 0.047. Remember that this is our BS meter, and that if our BS meter is 0.2 or less, it means that we have a real result that we can pay attention to. If you want to be really advanced, you could look at this and say, look, there's a 4.7% chance that this is some bullshit. That means that there is a 95.3% chance that we are observing a real result. This passes our test of statistical significance. This is real, okay? Remember, in a correlation coefficient, always look at the sig2 tail test first. Then you can move on to the correlation coefficient. Sig2 tails tells you if there's a real relationship. The Pearson correlation coefficient tells you how big the relationship is. So you have to make sure the relationship is real before you see how big it is. In this case, the Pearson correlation coefficient is negative 0.282. Remember what we said about correlation coefficients. We said that anything of absolute value 0.2 or higher was a very strong correlation in the social sciences. So what you would do here to write up the first part of this question, you would say something like the sig2 tail test is 0.047, which is well below our threshold of 0.2. Therefore, we know that we have observed a real relationship. That's period. Then, the Pearson correlation coefficient is negative 0.282. And that is a very strong correlation. So this indicates a very strong relationship between the two. All right. On the question here about how strong is this relationship, remember, the real systematic part is the test of statistical significance. The how strong is the relationship is the correlation coefficient. All right. I'm going to do number 4 here. I don't think I'm going to do number 5. All right. So you've got the variables here. And what we're asking is, how large is the real effect of an increase of 1 percentage point in a state's over 64 population on the percentage of its state's legislators that are Democrat when the percentage of the population with a college degree, the percentage of the population that is unemployed, and the percentage of the population that belongs to a union are all controlled? All right? When you hear me talk about a multivariate situation, that is to say, when we're dealing with the relationship between more than 2 variables, that is regression analysis. All right? When you hear me say that I want to see the impact of one variable on another, that is multiple regression analysis. All right? Because I can't, remember, we can't use the correlation coefficient to demonstrate effect size beyond very strong, and strong. All right? Also, when you hear that I want to hear the effect size of one variable on another when other variables are controlled, if you hear a multivariate situation, that's regression analysis. That is especially when you hear language about controlling for other variables. All right? So we got to go into SPSS. Before we do, I want to show you something, all right? Remember, the thing that we are predicting is always the dependent variable. So in this case, the outcome that we want to predict is the percentage of the state legislators that are Democrats. All right? The thing that does the prediction is the independent variable. All right? So, how large is the real effect of an increase of 1 percentage point in a state's over 64 population on the percentage of its state legislators that are Democrats? All right? The thing that we want to predict is the percentage of state legislators that are Democrats. The thing that we think is going to do the predicting is the independent variable. The controls are also independent variables. What does that mean in terms of SPSS? All right? Let's go back in here. Let me see this. Sorry, I'm working with the